galvanic cell or voltage cell. A device in which in which the chemical energy produced in a spontaneous redox reaction is converted into electrical energy. So here chemical energy is being converted into electrical energy. In electrolytic cell, what did you find? In electrolytic cell, we found that energy has converted into chemical energy. In this process, the non-spontaneous processes are carried out. Okay, so here it is like this. So I'll give you a description on the cell. How do you do it? I think some school already have done electrochemistry, so they know it. In this case, the reaction is carried out in two different cells. Okay. Here also by convention we write cathode on the right and anode on the left. And this is being connected through by an U2, which is an inverted U2. Okay. I'll discuss everything, don't worry. Okay. Now in this galvanic cell, the cathode is made up of copper and anode is made up of zinc. And here you have copper sulfate solution. We take here 1 molar. Okay, and here we take zinc sulfate solution 1 mole. Okay. Now this is being okay. Now you have a switch here. I'll write like this. Okay, call it E. Okay, I'll write it outside. So you can, this is a switch, and it's being connected to a galvanometer. Galvanometer. Okay, I'll switch on this. So I'll write like this. And here in the galvanometer, it will read 1.1 volt. All right. Now, before I do anything, let me go back to some other story. Say, I have taken a beaker containing copper sulfate solution. Right, how this pale blue. Okay, and I dip here one zinc rod. Okay, zinc rod. Then I kept it for some time. You can keep it for 2-3 days also, no problem. Then you find gradually the pink color of the solution fades, and shining copper metal is deposited at the bottom of the flask. And also on the zinc rod. All right. So this is happened. So let me write the equation. I write down here.
Sir.
Yes.
From where do we get the pink color, sir?
But pink. It is copper solid pale, not pink. Hey. P-A-L-E.
Sir, gradually the pink color, sir, you wrote.
Shano, hey, क्या pink लिखेगा? Pale, P-A, pink का spelling क्या P-I से होता है ना P-A से होता है?
Gradually the pink color.
Oh, yes, this is good. Usually the blue. Pale blue. solve right now. Zinc, this is solid. Copper sulfate aqueous. It gives us what? Zinc sulfate is colorless, and the copper has, this is the solid copper deposits. So let us see how does it happen. So what I will do now, we have found nothing has happened to the sulfate. So I'll remove this. I'll write like this. Zinc S, copper 2 plus aqueous is giving us Zn2 plus aqueous and copper S. This is the ionic equation. Now we have to see a little more. How does it happen? Okay. So let me write it here. After this, you write this. See here, what happens? Zinc loses 2 electrons. And copper 2 plus aqueous plus 2 electron will give you copper S. What happens here? This is oxidation. And this is what? Reduction. When I add it, so this and this will get cancelled. So zinc S plus Cu2 plus aqueous Zn2 plus aqueous plus copper. So this is the same thing we have written.
Done, sir.
Okay. So now we have found rubbing this portion. We have found whatever phenomenon that we have seen here. This is the actual thing. It is here oxidation takes place and reduction takes place. All right. So this the final equation consisting of 2 equations. So in this case, if it is one equation, then this is half and this is half that you have studied already in class 11. So what is this now? This is oxidation half reaction, and this is reduction half reaction. Okay. Now, in this electrochemical cell, this reaction does not occur in one flask. In this cell, oxidation takes place. In this cell, reduction takes place. Okay. So, what does it happen here? you'll find here zinc is going to lose two electrons. Then this, see here, very interestingly, what happened? This is made of zinc. So in this case, the zinc loses two electron on the surface, and jumps into the solution as zinc 2 plus. Just like that, suppose you want to jump in a swimming pool, you do not jump with your school uniform. Okay? You'll have a separate swimsuit. Okay? So you'll remove your uniform, then you'll jump into water. So similarly, it is like this. The zinc is going to leave this electron on the surface of the electrode and will go into solution. And this electron now will travel because if you switch on, circuit is complete, it will come and it will reach here. In this case, what is going to happen? See here, copper 2 plus ion in the solution because copper sulfate is a strong electrolyte. It will give you copper ion and sulfate ion is going to take this 2 electron and it will become copper. So what has happened? This cell is made according to this equation. Okay. So what should I write it here now? These two cells are not complete cells. These are half cells. Half cell. This is half cell. All right. Now, what type of half cell? This is oxidation half cell. So it is oxidation half cell, and this is please write down reduction half cell. Okay. Or we can call this term to be, this is called anodic cell. And this is cathodic cell. See, now externally it is being connected by a metal wire. What will happen to this? Because this is made of glass, this is also made of glass. So it is insulated. So this internal circuit is being completed by a salt bridge. The internal circuit is completed by using a salt bridge. So what is salt bridge? Salt bridge is consists of chemicals consists of salts which have similar ionic mobilities of both the cations and anions, and do not take part in cell reaction. Okay. What type of substances we use? Example, we use here potassium chloride, then you use potassium nitrate, or you use here ammonium nitrate, etc. I'll also draw it here. Electrochemistry is not difficult. See, the electron has arrived. Okay, and what you have now? Cu2 plus. Cu2 plus. It is coming here. Written, na? Okay. Now let us see. Let me talk something of the electrode. See, in electrolytic cell, cations goes to cathode. So because of that, it was a negative electrode. Anion is a negative ion. It goes to anode, so that is a positive electrode. Yes, the case is not same. See, I have told you, this zinc lose the electron on the surface of the electrode. So what is the charge on electrode? Negative. So this is a negative electrode. Please here. See, this is the basic difference between electrolytic cell and electrochemical cell. That is a negative electrode. So if it is negative electrode, this is the positive electrode. I'm not going to use any difficult word because I'm very poor in chemistry. Whatever way I have learned, I also teach you in the same. So this is the negative electrode and positive electrode. So now we have found two, till now we have got two differences in electrolytic cell and electrochemical cell. What is the first difference? Electrolytic cell consists of only one vessel. An electrochemical cell is made of two cells, two half cells. Okay, now see. So, second, in electrochemical cell, anode is negative and cathode is positive. But in electrolytic cell, anode is positive and cathode is negative. All right. Now let's see. Let's see what is the function of this salt bridge. See here. How did I take here? I have taken here 1 molar solution of zinc sulfate. So here I have taken here zinc sulfate aqueous. Okay. So here you will have now 1 mole. It breaks to give us zinc 2 plus aqueous and sulfate 2 minus aqueous. See, this 1 mole will break down to give 1 mole of zinc. Is it not? It will be 1 mole of zinc plus. And here we'll have 1 mole. We'll have 1 mole of this, 1 mole of this. But see what is happening here. Is it not for the solid zinc? N number of zinc 2 plus has gone into solution. Does it have any anion to stabilize? No. Cations and anions are not individually stable. So who is going to stabilize this? In this case, what has happened? This is anode. I'll now remove this. This two you have already know. So now it is anode. Now cathode. See here. In this, we'll write now here anodic cell, and this is cathodic cell. क्या हो रहा है इधर में? You have taken 1 mole of copper sulfate. 1 mole. It gives you 1 mole of copper ion. 1 mole. And 1 mole of sulfate ions. Now see here. In this case, zinc is added, na? So total number of the zinc becomes what? N plus 1 mole. Number of sulfate is only 1 mole. So the anion are less. In this case, is it not the N number of copper 2 plus is depositing with N number of 2 electrons to N number of copper? It is minus. All right. So the number of copper ion is decreasing, but nothing is happening to sulfate. So
Can you repeat again?
See here. Okay, I'll write it like this. Here, N number of zinc. See, that I already shown you, na? What has happened? It is lost N into 2 electrons plus N into Zn2 plus. So is it not added? Added or not? Don't subtract it. It's not an equation. It's already there. You are adding this much number of zinc ion. But sulfate is constant. Here from copper sulfate solution, copper ion is precipitating in the form of copper. So number of copper ion is decreasing, but sulfate is constant. What will happen? Reaction will immediately stop. Because cations and anions, you cannot have without their counter ions. What is going to happen? Low. In this tube, suppose you have taken a potassium chloride. So first of all, let me tell you how do you make it. Okay, we take, don't write, a saturated solution of potassium chloride. To that, we add a substance called agar-agar. This is a type of soil. In biology laboratory, you might have seen agar-agar. If you do not have this one, okay, no problem. You can add there gelatin. Gelatin you have seen, na? Gelatin you have seen or not? Hello.
Yes.
Gelatin is used to make different types of confectionery item. It's very sticky substance, na? So add it. So this is agar-agar or gelatin is being added in the saturated solution of potassium chloride. Then it becomes very thick. After that, we keep it in the fridge for a few hours. Then it becomes hard. Then this is the UTY. Okay. Now with the help of finger, we'll put it inside to pack it. Tightly we'll pack it. Okay. But if I tilt, it may fall down, no? So what I'll do, I'll put cotton plug. Then it's being inverted. So this is the way we make UT. Now, See here. See, these days are you not using YouTube? Huh? Hello.
Yes, sir.
Yes, sir.
Yes. This has come from this. This, if you are the person to receive, and the person who is supplying the information, this is the way there is being connected. Understood now where from the word YouTube has come now? Huh?
Yes, sir.
YouTube is a connection between the listener and the broadcaster. Okay. Now, this potassium chloride, because I made it a solution, not solid, strong electrolyte, K plus and Cl minus. See, in this case, what is more? Zinc, na? So immediately you'll find the chloride ion will rush to this side. So the chloride from here will come out through the cotton plug because it's already dipped in water. It will come here, and here you will find so much of chloride ion has come. Why? To neutralize the extra zinc. And I told you they have same ionic mobility because this reaction is redox reaction is simultaneous process. Okay, this is getting oxidized and this is getting reduced. So, moment the copper started precipitating out, the place of copper is being taken by potassium. Understood now? This is the reason for which. So, what is the purpose of this YouTube? First of all, YouTube completes the circuit of the electrochemical cell. Second, YouTube supplies the counter ion to neutralize the electric charges in both the half cell. In the anode, it will supply the anodic cell, it will supply the anion, and in the cathodic cell, it will supply the cations. Understood now? Any doubt? Hello? Is there any? Could you understand this portion?
Yes, sir.
Yes,
Now
sir.
it's clear now? Huh? So if
Yes, sir.
any question comes, what is the purpose of YouTube in the electrochemical cell? You will only write two. First, it completes the circuit of the electrochemical cell. So this is the internal circuit, then this is the external circuit. So internally it is being connected through YouTube, and externally it is being connected through metallic wire. Second, it neutralizes the it goes for this electrolytic cell. It neutralizes the charges in the both anodic and cathodic cell by supplying the respective ions to those cells. Understood now? Okay. Now, can I rub it? This portion? Okay, I have rubbed. So now I have to tell many things. See here. So from this thing, what is happening? I told you, no, electrons are there. So electrons started flowing. This is the electrons are flowing. So now, but is it not a negative cell? And this is a positive cell. So we call this one to be electronic current. I tell you why. Is electronic current. Migration is taking place. But what do we say now? In this direction, what flows? Electricity. See, it's very funny. We know moment of electrons is nothing but a moment of electricity. But here we are writing ulta. Why you are writing ulta? See there, this is simply convention. Because this is a positive and negative. We always say positive is higher than negative. Okay, in this case, this fellow doesn't have any electron to supply. Only because by convention we have put it as a positive. So because of that we say electricity moves from cathode to anode. And electron moves from anode to cathode. So what we can write now here? Note, what we'll write? Electrons move from anode to cathode. Okay, we'll write now here. Electronic current. And second, electricity moves from cathode. Here I'll write intentionally within bracket positive electrode, just to maintain our tradition. Positive electrode to anode. It is negative electrode. So when it goes through that, we record a potential difference. Potential difference of 1.1 volt. Why do you get 1.1 volt? We'll see it later. We'll calculate and find it. Okay? So this is the story of the electrochemical cell. Initially, it is being studied with the voltaic and interpreted by this. So it's called galvanic cell and voltaic. Please remember, we can have different types of electrochemical cell. But when you say galvanic cell or voltaic cell, please remember, anode should be zinc, cathode should be copper, and the concentration of the electrolytes should be 1 molar. Temperature now 298 Kelvin. Pressure now 1 bar or 1 atmosphere. This is a condition for these two. But you can make as many as cells like this by changing the electrodes. In this case, we will call it as an electrochemical cell. Okay. So these names are of historical importance. All right. Now, I think you have to draw this on again. So you will remove all this here. Okay. We'll remove everything from here. And we will remove all this thing from here. Okay. We'll write here a note. Right here, cell negative electrode. Please draw it again. Negative electrode, and we'll write here now zinc S. Here we'll write positive electrode, and here we'll write copper. We'll remove all these things. Okay. I'll not write anything because now we know that it is a galvanometer that we know. Okay. Okay, I'll write here electricity. is moving in this direction. Now what I'll do? This I'll connect it to an external circuit. This is the internal circuit. And this is the external circuit. And this is the resistance. I feel bad because you are not able to do practical, na? This would have been done in your lab. This resistance in laboratory, what we call it? We call it rheostat. So in rheostat, it's just a cylindrical thing, huh? It is a cylindrical thing, all right? Where you'll find a grip is there. If you move up and down, you can reduce the control the flow of electricity. It's like this. One holder is there, and it is like this. It will move like this. Okay, it will move like this. You can control. You can increase, decrease. Like say in your hot plate, you can control the flow now, just like this. Yeah, the condition is that in external circuit, electricity will flow in an opposite direction. So we'll see here. We are doing this experiment. So condition. When no current flows in the external circuit, the electrochemical cell produces a potential difference of 1.1. So it is 1.1 volt. Second, when potential is gradually increased in the external circuit, the potential of the internal circuit drops till it reaches 1.1 volt in the I'll not make a separate sentence. When the potential difference difference in external circuit reaches 1.1 volt. The electrochemical cell stops functioning. That is, it does not produce electricity. Okay, now after that you finish, then I'll write the third one. When the potential difference in the external circuit crosses 1.1 volt, the electrochemical cell behaves as electrolytic cell. See, now it does not produce electricity at 1.1 volt. When you cross here more than 1.1 volt, then in that case, what has happened? Now it behaves like an electrolytic cell. That is, here the cathode becomes negative, anode becomes positive. All the copper which got deposited on the surface of this electrode, all the copper now starts moving, going down the solution as copper ion. Electron comes all the way here, and zinc ion takes electron and it becomes zinc. See, it's very interesting. Every day that this one you are doing in your home. You know, this is the technique by which you charge your mobile battery. Mobile battery is an electrochemical cell which produces electricity. But there is, because you are using electrode. So if you continuously use this cell, what will happen? A time will come, zinc rod will not be there. All the zinc rod, when it comes out, is it not, it will get dissolved? This rod will not be there. In that case, will the cell work? No. So in that case, what happened? Maybe after, if you have used for a long time, maybe after 2 hours, you may have to charge it. If you use it less, maybe that you may charge it after 1 day or 2 days. In that case, when you see, do you not connect it to our cell charger? Charger is nothing but the external circuit. Current comes from your plug point and it moves in the opposite direction of the electricity generated in your battery. So all the anode which has dissolved in the solution of your battery and all the cathode that got deposited here, now they become reverse. So all the copper which is deposited here, they come back to the solution as copper ion, and all the zinc ion which got deposited here, it goes to the electrode as zinc rod. So again your battery become fresh. See, very interesting. Nobody could even thought that such a experiment which has been done maybe 150 years back can be utilized so nicely in our charging of our battery. Okay, so this is the story of the electrochemical cell. All right, understood? Hello.
Yes, sir.
Achha, now the question is that why some metal should lose electron and why iron should take electron? Let's see. So we are going to talk something of the electron. So I have taken a beaker containing electrolyte. Okay, electrolyte is there. Electrolyte is there. So it is having, say, this is the metal ion. We do not know how much charge it has. Mn plus. So it is being containing Mn plus ions. Okay. So here what you have now here, Mn plus, Mn plus, Mn plus, Mn plus, Mn plus. So it may be zinc ion, copper ion, any other. Huh? And this is the electrode that we have put it. So all the metal ions are here is M. Okay. So all the metal ions are moving inside the beaker and coming because it is liquid will come and hit on the surface of the electrode. So there are three things can happen. Okay, three things can happen. One. So I'll show you with human face. Okay. Okay. So these two persons are not looking at each other, indifferent. So it will be their attitude is indifferent. This is the second cause. Second, it will be like this. Okay. So this person is indifferent. Okay. But this person wants to interact. Third, it is okay. like this. In this case, this interaction is there. So here, what will happen now? M may like to interact with Mn plus. How do they interact? By giving electrons. Second, it may be that Mn plus is asking for electron. Here M plus wants to give electron. Asking, should I give you electron? And in this case, this is giving the asking for electron. So these are the three things can happen within that when you drop a metal rod into a solution containing the same ion. All right. So these are the things can happen. All right. Now we'll come across a term called electrode potential. Electrode potential. What is electrode potential? It is the potential difference between metal and its ions. Why there should be potential difference? Why there should be energy difference? Obviously, there will be difference of energy because metal is electrically neutral. Why it is electrically neutral? Because it is having same number of protons and electrons. So it is electrically neutral. And in case of ion is what? It is having less electron. So we know electrical charge depends upon the number of electrons present. How do you calculate? We calculate by knowing the number of electrons into each electron has a charge of 1.66 into 10 to the power minus 19 coulomb. So obviously there will be a difference between their potential difference will be there, energy difference will be always there between these two. So this is we call it electrode potential. All right. So on that basis, you'll find some may like to take electron and some may like to give electrons. Okay. Now, if it is measured, by dipping an electrode in 1 molar solution at 298 Kelvin. Okay, then see we have fixed this condition by ourselves. Okay, whenever you fix something, we call it standard. Then it is known as standard electrode potential. Standard electrode potential.
Done, sir.
Okay. Now we can classify this electrode potential into two types. Electrode potential or standard electrode potential are of two types. What are those? One is called oxidation potential. So what is oxidation potential? It is the tendency to lose electrons. To what? To form Mn plus ions. Example N. I'll write now here Mn plus N electron. All right. So this is a general one. I'll write some specific one that we have already done. This one, zinc. Zinc. I'll write here. So it will give you what? I'll write here zinc 2 plus aqueous plus 2 electron. This is solid, no? Or I can write here hydrogen gas will give you 2H plus aqueous and 2 electron. So you may object. Sir, this is non-metal only. Why you should behave as an electrode? Hydrogen is an unique. Hydrogen is a unique substance. Okay, I'll show you why. I'm only rubbing this portion. See here. What is the unique thing of hydrogen? See, hydrogen gas cone, if you bring it near chlorine in presence of light, it will immediately gives you hydrogen chloride gas. See here. HCl, does it not dissociate H plus and Cl minus? So what has happened? Hydrogen has lost electron and become this. Okay? So this one you need not write. This is for your just to understand hybridity, so that you should not have any doubt. That why we know that metals conduct electricity. Non-metals are not supposed to conduct electricity except graphite. Then why should hydrogen conduct electricity? This is the reason. So this is called oxidation potential. Now, what will be the second one?
Reduction potential.
Yes. So we write now, just we write ulta. So what we will write now here? Reduction potential. Reduction potential. What should we write now here? It is the tendency of metal ions to get reduced. Okay, get reduced. Of course, exception will be hydrogen get reduced. So what I can write now here? I can write here now Mn plus aqueous plus N electron. It will give me solid metal. Example, I'm giving from the galvanic cell. CO2 plus 2 electron, you will get here now copper solid. Again, I'm giving an example. You may raise question. 2H plus 2 electron will give you hydrogen gas. So again, for you, I write. See, when you add zinc in HCl, all of us, you know, it gives us hydrogen. What happens? Now you know a little bit. Zinc will give you zinc 2 plus 2 electron. So from HCl you get 2H plus 2 electron. It gives us hydrogen gas.
Done, sir.
Okay. Now see here. What will write down here? We know oxidation is reverse of reduction. So the magnitude of oxidation, standard oxidation potential, and standard reduction potential is saying only the sign changes. Say you have gone to market. Okay, you gone to the market. This is the counter, and here the owner is there. So he takes some money from you. Say you have paid him 100 rupees. So 100 rupees for you is negative. What happens? Does it not get 100 rupees? He gets 100 rupees or not? So in that case, you'll find the amount of money is 100, magnitude is 100, value is 100. But for you, you have given, so I have to put a negative sign. He gains it, so for that I'll put a positive sign. So in that case, what is going to happen? The value is same, but only the sign will be different. All right. So oxidation potential and reduction potential, the value is same, the sign is different. When you go subsequently, you'll find for reduction, though when they lose electron, we put a negative sign, and those who gain electron, we put a positive sign. We know the substance which undergoes loss. When it undergoes loss, we call it oxidation. But for what the electron is being used? This electron is being used for reduction, and anyone who takes electron, it gets reduced. But what is their purpose? It helps other to lose electron, so it's called oxidation. So we'll find later on, for reduction potential, we put a negative negative sign means loss of electron. Don't get confused. Metal loses electron. If you look at from the metal side, it is oxidation. But this electron is being lost for a purpose. What is the purpose? Purpose is the reduction. All right. So in that case, we put a negative sign, and for oxidizing agent, it pulls the electron of others. So for it is gain. Okay. So for we put a positive sign. So for reduction potential, the sign is negative, and for oxidation potential, the sign is positive. So next day we'll do to find out how to find out the oxidation and reduction potential of the electrodes. Because if I start, it will going to take on 1 hour. Okay. Bye. Good night.